The focus standard for this lesson comes from Grade 8, Expressions and Equations, Standard C, Analyze and Solve Linear Equations. Our topic for today is still from simplifying and solving equations, and we're focusing on three types of solutions when solving equations. So we're going to be putting both of these things together, we're going to be solving them and analyzing the solution that we get. And our essential question today is, what are the possible types of outcomes when solving equations? So go ahead and take a moment pausing the video if you need to set up your header. Be sure to include today's date, side of your question column, and your note column, and let's go ahead and jump in. So there are three possible types of solutions that we will get when we are solving equations. And the first one is the one we've seen the most, exactly one solution. We know we have this when we get x is equal to some number. For example, in the last video, the problem we did, we got x is equal to 2. So there's exactly one value, 2, that x can be. There's a no solution, and that means you do all the steps 1 through 3, and you get down to where you get two different values, and b, so two different values which cannot be equal. So an example like -3 cannot be equal to 1. So if I've done steps 1, 2, and 3, meaning I've simplified, I've balanced, and I've tried to isolate the x, if I'm trying to do that, and I get something like this, then what I have is no solution. We're going to talk about what that means when we see it down below. And then lastly, we have infinite solutions, where we get something like x is equal to x, where we get the same value on both sides of the equation. It might be a variable, like this, or it might be a number. For example, 3 is equal to 3. And this happens before you test the solution. So if you do get this, then it means that, well, that there's infinite solutions, and we'll talk again more about that when we see the example. So we're going to do three different problems and keeping our eyes out for each of these three types of solutions. Let's take a look at our first one. So here's our first one, and I want to just point out, I'm going to write it and as well as say it. I want you to use both methods, the expression mat and the traditional algebraic method. I've written my expression mats this time out horizontally. If you like doing it vertically and trying to set it up as a 5-column table and doing it all together, you can. So here's our first problem. So let's go ahead and record what this would be in our equation. And the explanation for that first step is just going to be the original equation. So you should have an equation that looks like this. We have 5x minus 6 here on the left and 3x minus 8 on the right, and we're setting those equal to each other. So our first move that we normally do is simplifying, but this is already simplified on the left and on the right. All of our x's are together in one term, and our constants are here in one term, same here and here. So we don't need to simplify anything. So what are we going to do next? Well, we're going to try and balance and get all the things to one side. And we could do this a few different ways. We can look on our mat and say, well, there's some things here, 3x's and 3x's and 6 negatives and 6 negatives. I could balance it out by removing it. So let's try that. It's going to look a little bit different down here, remember, but on our mats, that's what we're going to want to do. So we were looking for these to balance, and so I went ahead and did the 3x's first. So you can see that I'm circling these and pulling them off because they balance. And we talked about how there's -6's, but I'm going to hold off on that so we can make it match what we have down here below. So let's take a look at what we're starting to balance. So we saw that we had 3x's on both sides that we could take away. And that's easy to do here, right? I have 3x's here, and I can take them away from both sides. And what I have left is 2x on the left and a -6 on the left. And that's equal to now -8 on the right. So before with just the maths, what we were doing was just saying, well, I have these and these I can just subtract off. Well, in traditional algebra, we can't just pull off negatives. Negatives are really where it becomes a problem. And so what we're learning to do is to zero those out. So if I want to get all the x's to one side, I already have that, but I want to zero out this -6 so that the x's are left alone. And so what I can do to zero that 6 out is I can add 6 positives to both sides. And that matches a little more closely with what we do here. So if I add 6, we know in traditional algebra that's going to zero this out. So it means I'm going to be able to take all of these here and pull those off. And I'm also going to be able to do that with these. So by adding 6 to both sides, what I was left with was 2x is equal to -2. And I see 2x is equal to -2. So I balanced it with this kind of odd step. It matches closely to more traditional algebra, but not quite what we've done on the mats. So hopefully you're following here. We subtracted 3x from both sides, got 2x minus 6. We wanted to get these x's all by themselves and zero out this -6. So we added 6 to both sides. And we do that, -6 plus 6 makes 0, leaving us with just 2x. And it left us with -2 on the right. So we were successful in getting all the x terms to the left side and all the constants to the right side. So we're ready for our next step, which is to isolate x. We want to find out, well, what is just one x equal? So we could just say, well, I have two things, let's make two groups. And so I can say, well, that's a group, and this is a group. And each group has the equal amounts. They each have one x and one -1, and one x and one -1. So we want to show what that's going to look like. And I just copied this down again, 2x minus 2, but we divide both sides by the coefficient. So 2x has a coefficient of 2. I'm going to divide by 2. If I divide by 2 on the left, I also have to divide by 2 on the right. So that leaves me with x is equal to -1. That's what we got in our circles. X is equal to -1. And then, of course, our final step here is to test the solution. So does it make both sides equal if I put -1 in? So start with our regular equation, plugging -1 in for both sides, and going through order of operations, and it does. It ends up being a -11 equals -11. And so we can say, well, yeah, our final answer is x is equal to -1. And as far as the type of solutions, that looks like this. So we have exactly one solution because x is equal to -1. That is the only value that will make this left expression, 5x minus 6, equal to 3x minus 8. If I try anything else for x, it won't work. It will not be equal on both sides. So that's our first example, and that's what we've seen the most of. Let's take a look at a second example. So here's our second one. I have it on an expression mat. Go ahead and write down what the equation is going to be, with an expression on the left being equal to the expression on the right. We're going to say that that's our original equation. So I'm looking for something along the lines of 2x plus 3 for the left and 2x plus 7 on the right. Again, this is already simplified. There's nothing to flip up. X terms are together as well as constants on both sides. So we're going to jump right into the balancing step. So we can see that there's two x's on both sides that we can subtract. We can see that in our equation too. So we're going to do that. And if I subtract two x's, I'm showing that on my expression mat as well as down here on my table. I'm going to get 3 and 7. The 3 left, and then we know that that's not equal. And I could take it a step further. I think I do on this mat. I do. So we could say, well, there's also, and since it's positive it works out on the mat to do this, I can subtract 3 on the left, and I can subtract 3, let's see if I can circle just 3. And I can subtract 3 on the right. If I subtract 3 from both sides, I end up with 0 on the left and 4 on the right, and those values are not equal. Those are not the same. And so we can give an explanation of the left expression can never be equal to the right. There's no way here for that to happen for any value that I put in for x. And so this is an example of no solutions. We'd say our final answer is that 0 does not equal 4, and therefore this is a no solution. Let's take a look at one final problem. So here we have our expression mats. We're going to follow the same process. So looking at what we have on our mat for both the left and the right, we're going to write our equations, and I would look for 4x plus 3 on the right, on the left. On the right we have 2x plus 1 minus the quantity negative 2x minus 2. So now we definitely need to simplify. We need to flip tiles and we need to combine like terms. Go ahead and do that on your mat as well as on your algebra table here. So you can see I've done that. I've circled that. I'm going to flip these tiles up, and here's what I end up with. And then as far as doing this on my table, I realize that there's a sneaky negative 1 here. The left is fine. There's a sneaky negative 1 out here, so I'm going to have to distribute that. So negative 1 times negative 2 gave me this positive 2. So I kept the 2x plus 1. And negative 1 times negative 2x gave me this positive 2x. So I did my distributive property, and now I've started to highlight things that are the same. So if I take 2x plus 2x, I'm going to get 4x. And if I take 1 plus 2, I'm going to get 3. So we're starting to see something here. We got 4x plus 3 on the left. That's been the simplified version of that the whole time. And now as we start to simplify the right expression, we're getting the exact same expression on the right. So that should raise some eyebrows. But we're going to stick through following mathematics and the steps for solving, and we're going to balance them. We're going to try and get the x's to one side and the constants to the other. So first thing we're going to do is subtract off 4 x's from both sides. And that's going to leave me with 3 is equal to 3. And I could probably stop here, but I'm going to take it one step further, and I'm going to subtract 3 from both sides, because there are 3 positives on both sides of the mat still, and on both sides of our equation that we can subtract off. And if we do that, subtract 3 from both sides, we end up with 0 is equal to 0. So here is an example of where the left expression will always be equal to the right expression. So we started to see this. This is what I was saying. This might raise some eyebrows. And so if it's the exact same expression, no matter what we put in for x, we're always going to get the same thing. We can put any number in for x on the left and on the right, we're going to get the same value. So our final answer is 0 equals 0, which gives us infinite solutions. Exactly what we were just saying. We can plug any number in for x, and we're going to get the same answer on both sides. So that concludes our video for today. Please make sure you have all 3 examples on both the expression mat, and we see that here 0 is equal to 0, and the tables for all 3, and come ready to discuss these different types of solutions in class.